Rational expressions look like fancy fractions, but they are really polynomial fractions. The SAT tests whether you can simplify safely, add carefully, and respect domain restrictions, often in multi-step questions that also test factoring. If you treat them like regular fractions, but remember denominators cannot be zero, you will stay in control under time pressure. Let us build the core idea before we touch any harder algebra. A rational expression is a ratio of two polynomials. You simplify by factoring, then canceling common factors, never canceling individual terms that are added or subtracted. Every time you cancel, you must track values that make the original denominator zero. Those values are not allowed, even if they look tempting after simplification. When you add or subtract, you need a common denominator, just like numeric fractions. When you solve an equation, multiply by the least common denominator to clear denominators, then check for extraneous solutions. Keep that three-part flow in mind. Simplify, combine, solve. The SAT mixes all three in one test. When you defactor early, you also see hidden structure. Difference of squares, common factors, and sums that collapse cleanly. That structure is exactly what the College Board expects you to notice under time pressure. Example 1, easy level. Simplify this x squared minus 4 all over cx minus 2. Factor the numerator as a difference of squares. You get x minus 2 times x plus 2 over x minus 2. Now cancel the common factor x minus 2. The simplified form is x plus 2. State the restriction x cannot equal 2 because the original expression is undefined there. Example 2, medium level. Add 1 over x plus 1 plus 2 over x minus 1. The least common denominator is x plus 1 times x minus 1. Rewrite each fraction. The first becomes x minus 1 over the LCD. The second becomes 2 times x plus 1 over the LCD. Combine the numerators. X minus 1 plus 2x plus 2 equals 3x plus 1 over x plus 1 times x minus 1. Restrictions here are x not equal to -1 and x not equal to 1 from the original denominators. Example 3, harder SAT style. Solve x over x minus 3 equals 2 plus 3 over x minus 3. Multiply both sides by x minus 3, assuming x is not 3. On the left you get x, on the right you get 2 times x minus 3 plus 3. Expand x equals 2x minus 6 plus 3, so x equals 2x minus 3. Subtract x from both sides. 0 equals x minus 3, so x equals 3. But x equals 3 makes the original denominator 0. That means the candidate is extraneous. This equation has no valid solution. Common mistake, canceling terms instead of factors. Students cross out pieces inside a sum, which breaks algebra. You may cancel a factor shared by the entire numerator and denominator. You may not cancel an addend that appears in only one part. If you're unsure, factor completely first. Factoring reveals what is actually multiplied, and safe canceling becomes obvious. SAT pro tip, factor first, always. Factoring exposes restrictions, reveals common factors, and prevents sloppy canceling on timed questions. On multiple choice, plug answer choices only after you respect domain restrictions, or you might pick a value that was never allowed. Recap, 3 ideas to keep. First, factor, then cancel shared factors. Never random pieces of sums. Yet second, track every denominator for restrictions and build the LCD for addition. Third, after you solve, throw out values that break the original denominators. Practice more on NovaMaths.